And now in this lecture we'll find out the radius of a circle. In the drawing we have a circle, chord AC equals to the square root of 2 units in its length, chord DB equals to 2 units in its length. This is angle DEB, that is equal to 45 degrees in its size, and our mission is to find out the radius of this circle. So first of all, we join points A and D together by a straight line. And we define the size of peripheral angle BAD, the size of this angle, that is peripheral angle BAD, as x over 2. Again, angle BAD, this angle, peripheral angle BAD equals to x over 2 degrees in its size. Peripheral angle PAD, this peripheral angle subtend on chord DB. We will define the center of this circle. This point is point O. From the center of this circle, that is to say, we will join points O, that is the center of the circle, with point D. Likewise, we will join points O with point B. Actually, by doing this construction, we created here center angle DOB. This is the center angle DOB that subtend on chord DB. Again, this center angle DOB, the angle in the red color, constant on chord DB. And peripheral angle BAD, this peripheral angle BAD also subtend on the same chord called DB. So here we can implement rule 13. I repeat quickly on rule 13. According to rule 13, a certain angle is twice as large as the peripheral angle subtended on the same chord. So at the moment we have a circle, and we have this is peripheral angle ACB that subtend on chord AB, and the size of this peripheral angle ACB is theta. In addition, in the drawing we have also center angle AOB. This is center angle AOB that subtend on the same chord called AB. And according to this rule 13, the size of peripheral angle, the size of center angle AOB must be twice as large as the size of this peripheral angle ACB. The size of peripheral angle, because they both subtend on the same chord called AB. The size of the peripheral angle ACB is theta, therefore the size of this center angle AOB must be equal to 2 theta. So we can actually implement rule 13 in our drawing. Why? Because in our drawing we have here peripheral angle BAD. This is peripheral angle BAD. The size of this peripheral angle BAD is x over 2 according to our definition, and peripheral angle BAD subtend on chord BD. We have also here center angle BOD. This is center angle BOD that subtend on the same chord called BD. Therefore, the size of this center angle must be twice as large as the size of this peripheral angle BAD. So the size of this peripheral angle is x over 2. Therefore, the size of this central angle BOD that is subtend on the same chord called BD must be equal to x. Okay, according to rule 13. Okay, in the next step, we will define the size of this peripheral angle ADC as x over 2, as y over 2. Again, the size of this peripheral angle ADC is equal to y over 2 degrees, and this peripheral angle ADC subtend on chord AC. From we join points O and A together by a straight line. Likewise, we join we join points O and C together by a straight line. By doing this construction, we created here center angle AOC. This is center angle AOC, and center angle AOC subtend on chord AC, exactly like peripheral angle ADC that subtend on the same chord called AC. Therefore, the size of the center angle AOC must be twice as large as the size of this peripheral angle ADC. Peripheral angle ADC equals to y over 2 degrees inside. Therefore, the size of center angle AOC is subtend on the same chord called AC must be twice as large, and this peripheral angle ADC. So the size of this peripheral angle is y over 2. Therefore, the size of the center angle AOC is subtend on the same chord called AC must be equal to y, according to rule 13, of course. Okay. Here, point O is the center of the circle, point B is the point on the circle itself. Therefore, OB is the radius of this circle, that is the radius that we are looking for. We define the radius of this circle OB as R, therefore OB equals to R. Likewise, OD is also the radius of this circle, therefore it is equal to R. OC is also the radius of this circle, that is R. And finally, AO is the radius of this circle, that is equal to R units in its length. Again, R is the radius that we are looking for in this question. In the next step, I'll copy triangle BOD in a new page, and we will implement the law of cosines in this triangle, triangle BOD. But before that, we have here the triangle ADE. So I'll copy this triangle AED in a new page, and we'll implement rule 4 in this triangle AED. Hopefully, this is a triangle AED that I copied from the original drawing. In this triangle AED, those two angles x over 2 and y over 2, and this angle also, they are all defined as the interior angles of this triangle ADE. And this angle BED that is equals to 45 degrees in its size, it is defined as an exterior angle in relation to this triangle AED. Okay, so here we can implement rule 4 in the drawing. I'll repeat quickly on rule 4. According to rule 4, the exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So, in the drawing we have a triangle, and those two angles A, B, and C, they are defined as interior angles of this triangle. Why? Because they are located inside the triangle. Therefore, those three angles A, B, and C, they are all defined as interior angles of this triangle, and this is angle E that is defined as an exterior angle. Why angle E is defined as an exterior angle? Because it is located outside the triangle, this triangle, and therefore it is defined of an exterior angle. So this exterior angle E, according to this rule 4, equals to the sum of the two interior angles that are not adjacent to it. This is angle C adjacent to angle E, therefore the two other angles that are not adjacent to this exterior angle E are A and B. And according to this rule 4, the size of this exterior angle E equals to the sum of the two interior angles that are not adjacent to it. The two interior angles that are not adjacent to this angle E are A and B. And therefore the size of the exterior angle E equals to A plus B. Again, the size of this exterior angle E equals to A plus B. So we can actually implement rule 4 in our drawing. Why? Because in our drawing we have this triangle ADE, and this is angle DEB. This angle DEB equals to 45 degrees in its size. And the two interior angles that are not adjacent to this angle DEB are x over 2 and y over 2. And according to rule 4, the size of the exterior angle DEB, that is 45 degrees, angle DEB equals to the sum of the two interior angles that are not adjacent to it. That is to say, angle DEB equals to x over 2 plus y over 2, because those two angles are not adjacent to this angle DEB. So I write it down. I should find out that according to rule 4, the size of an angle BED, the exterior angle BED, it is equal to the sum of the two interior angles that are not adjacent to it. That is to say, it is x plus 2 plus y over 2. According to rule 4. Angle BED equals to 45 degrees, so we substitute angle BED by 45 degrees. So 45 degrees equals to x over 2 plus y over 2. Here we multiply this equation by 2 and finally get that x plus y equals to 45 degrees times 2 is 90 degrees. So x plus y equals to 90 degrees, we subtract x from this equation, and finally we get that this will be equation 1. According to equation 1, y equals to 90 degrees minus x. Y equals to 90 degrees minus x. This is angle y that equals to 90 degrees minus x. In the next step, I will copy triangle ODB, this triangle ODB in a new page, and we will implement the law of cosines in this triangle ODB. Again, angle BOD equals to x degrees in its side. Side OD is the radius of this circle that is R. Side OB of this triangle OBD equals to R also. And finally, side DB equals to 2 units in its length according to what is given in the question. This is triangle OBD that I copied from the original drawing. Now we will implement the law of cosines in this triangle OBD. So I put quickly on the law of cosines. Going into the law of cosines. First of all, the law of cosines is true in any triangle. So this is triangle ABC, that could be any triangle. In triangle ABC, side AB equals to A units in its left, side AC equals to B units in its left, and side BC equals to C units in its left. Angle BAD, this angle equals to theta degrees in size, according to the law of cosines. Cosine theta equals to a square plus b square minus c square over 2 times a times b. Again, cosine theta equals to a square plus b square minus c square over 2 times a times b. So we can actually implement the law of cosines in this triangle BOD, DOB, or ODB. According to the law of cosines, in the triangle ODB, cosine x will be equal to OD square. OD is R, therefore OD square is R square, plus OB square. OB is also R, therefore OB square is R square, minus BD square. BD is 2, therefore BD square is 2 square, that is 4, minus 4, divided by 2 times OD, that is R, times OB, that is also R. So in conclusion, we shall find out that according to equation 1, cosine x equals to R square plus R square minus 4 over 2 times R times R. So cosine x equals to R square plus R square is 2R square. So the numerator of this expression we have 2R square minus 4 in total, divided by 2 times R times R. 2 times R times R is 2R square. So we shall find out that according to equation 1, cosine x equals to 2r squared minus 4 over 2r squared. 2r squared over 2r squared is 1. So this expression equals to 1 minus 4 times 2r squared. Here we divide both the numerator and the denominator of this expression by 2 and get that in total the value of this expression will be equal to 1, and we have here minus 4 over 2 is minus 2, and 2r squared over 2 is r squared. So in conclusion, we found out that according to equation 1, cosine x equals to 1 minus 2 over r squared. Repeat again. We have found out that according to equation 1, cosine x equals to 1 minus 2 over r squared. In the next step, I'll copy triangle DOB, this triangle DOB in the new page, and we will implement the law of cosines in this triangle DOB. Side OD equals to r, it is the radius of this circle, that is the radius that we are looking for. In this question, side OB also equals to r. And the length of side DB is 2, according to what is given as the question. So this is triangle DOB to the copy from the original drawing. Now we will implement the law of cosines in this triangle DOB. So according to the law of cosines, so here we actually finished with the triangle DOB, and in triangle DOB, this is angle x, and we already found out that cosine x equals to 1 minus 2 over r squared. So we actually finished with triangle DOB. So in the next step, I'll copy triangle AOC in the new page, and we'll implement the law of cosines in this triangle AOC. Actually, this is triangle AOC that the code from the original drawing. Now we will implement the law of cosines in this triangle AOC. According to the law of cosines, in triangle AOC, this will be equation 2. Cosine y will be equal to AO square. AO is out, therefore AO square is R square plus CO square. CO is also out, therefore CO square is R square minus AC square. AC is square root of 2, therefore AC square is square root of 2 square. That is 2, so it is minus 2 divided by 2 times R times R. According to this equation 2, we actually found out that cosine y equals to R square plus R square is 2R square. So total the numerator of this expression we have 2R square minus 2 divided by 2 times R, that is 2R square. So this expression equals to 2R square over 2R square is 1 minus 2 over 2R square. So it is actually 1, and here we divide both the numerator and the denominator of this expression by 2. So minus 2 over 2 is minus 1, and 2R square over 2 is R square. So in conclusion, we found out that according to equation 2, cosine y equals to 1 minus 1 over R square again according to equation 2. This is equation 2. Found out that cosine y equals to 1 minus 1 over R square. But we have already found out that y equals to 90 degrees minus x, so already know. We actually found out that y equals to 90 degrees minus x. So here we can substitute y in this equation 2 by 90 degrees minus x. We do it now and we get that cosine y, and y is 90 degrees minus x, so cosine 90 degrees minus x equals to 1 minus 1 over R square. We have the trigonometric identity that states that sinus x equals to cosine 90 degrees minus x. So according to this trigonometric identity, we can substitute cosine 90 degrees minus x in this equation 2 by sinus x. We'll do it now, and we get that according to equation 2, cosine 90 degrees minus x is sinus x, according to this trigonometric identity. So Again, cosine x is x minus x is sinus x according to this trigonometric identity. So sinus x equals to 1 minus 1 over r squared. And again, if we found out that according to equation 2, sinus x equals to 1 minus 1 over r squared. This is according to equation 2, while according to equation 1, we have already found out that cosine x equals to 1 minus 2 over r squared. So we have here two expressions, one expression for sinus x and the other expression for cosine x. In the next step, we'll use the trigonometric identity. It states that sinus square x plus cosine square x equals to 1. And we already found out that sinus x according to equation 2 is equals to 1 minus 1 over r squared, and cosine x according to equation 1 is equal to 1 plus 2 over r squared. Now we can substitute sinus x in this trigonometric identity by 1 minus r over by 1 minus 1 over r squared, and we substitute cosine x in this trigonometric identity by 1 minus 2 over r squared. Let's do it now. And here we get equation 3 that states that sinus square x, so sinus x is 1 minus 1 over r squared, and therefore sinus square x will be equal to 1 minus 1 over r squared. So this is sinus square x plus cosine square x. Cosine x equals to 1 minus 2 over r squared. Therefore cosine square x will be equal to 1 minus 2 over r squared. And sinus square x plus cosine square x equals to 1. This is sinus square x, this is cosine square x, and the sum of those two expressions equals to 1 according to this algebraic identity. So if we found out that according to equation 3, 1 minus 1 over r squared plus 1 minus 2 over r squared equals to 1. Here we define t as 1 over r squared. Now we can substitute 1 over r squared in this equation 3 by t. We'll do it now, and again that according to equation 3, we have here 1 minus 1 over r squared, and 1 over r squared is t. So we substitute 1 over r squared by t, and it is squared. Okay, plus 1 minus 1 over r squared. Again, it is 2 times 1 over r squared. And 1 over r squared is t. So we substitute 1 over r squared by t. So in total, this expression equals to minus 2t squared, and it equals to 1. So according to equation 3, we actually found out that 1 minus t squared plus 1 minus 2t squared equals to 1. We open the brackets on this side of the equation, and we get that 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t. We have also 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared, that is 4t squared, minus 2 times 2t is minus 4t, and it equals to 1. So we found out that according to equation 3, according to equation 3, 1 plus t squared plus 2t plus 1 plus 4t plus 4t equals to 1. So here we have 1 on both sides of the equation, so 1 gets cancelled. So we cancel 1. On this side of the equation we have t squared plus 4t squared is 5t squared. And you have minus 2t minus 4t is minus 6t. Plus 1 equals to 0. Again, according to equation 3, we found out actually that 5t squared minus 6t plus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0, the variable that we are looking for is t, therefore x equals to t, the coefficient a equals to 5, the coefficient b equals to minus 6, and finally the coefficient c equals to 1. The only thing that is left to do is to put the data of our specific quadratic equation inside this general formula for x, and we find out the value of the values of t, because x equals to t. So we do it now and get that x equals to t, so we substitute x by t. T equals to minus b. B is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. B is minus 6, therefore b squared is minus 6 squared, that is 36, minus 4 times a. Minus 4 times a is 5, so minus 4 times 5 is minus 20, times 1, minus 20 times c, and c is 1, so minus 20 times 1 is minus 20, so inside the root we have 36 minus 20 divided by 2a. A is 5, so 2a is 2 times 5, that is 10. So I found out that t equals to 6 plus minus 36 minus 20 is 16. For instance, the root value of 2 is 16 divided by 2. So t equals to 6 plus minus the square root of 16 is 4 over 2. So think again. We actually found out that t equals to 6 plus minus 4 over 2. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 2. 6 plus 4 is 10. Actually, here we have t equals to 6 plus minus square root of 36 minus 20 over 10. It is not minus 2, not divided by 2, but divided by 10. So here we have 10, and here also we have not 2, but 10. So here we have not 2, but 10. And here also we have 10. So according to the first solution for t equals to 6 plus 4, that is 10, and 10 over 10 is 1. So t equals to 1, and according to our definition, t equals to 1 over r squared, so we substitute t by 1 over r squared in this equation, and we get that 1 over r squared equals to 1. Here we multiply this equation by r squared, and finally we get that 1 equals to r squared. Here we take a root out of this equation, and we get that the radius r that we are looking for is equals to the square root of 1, that is 1. So according to the first solution, the radius r of this circle is equals to 1 unit in its length. And actually the radius r of this circle cannot be equal to 1. Why? Because of the fact that we know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. And here we have chord dB, that is definitely not the diameter of the circle. Again, chord dB is not the diameter of the circle, and it is equal to 2 units in its length. So chord dB, that is not the diameter of the circle, equals to 2 units in its length. So now we know that the diameter 2r of this circle must be greater than chord dB. Again, the diameter of the circle, that is 2r, must be greater than chord dB, that is 2. Okay, so for this inequality, we will derive that the diameter 2r must be greater than 2. Here we will divide this inequality by 2, and finally we get that the radius r that we are looking for must be greater than 2 over 2, that is 1. So the radius r of this circle must be greater than 1. So the solution that the radius r equals to 1 is the correct solution. We cancel this solution, and we left only with the second solution that is possible for r. We have here two solutions for t. The first solution for t is that t equals to 1, and the second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So according to the second solution for t equals to 1/5. But according to our definition, t also equals to 1 over r squared. So we substitute t in this equation by 1 over r squared. And we get that according to this equation, t that is 1 over r squared is equals to 1/5. Here we cross multiply this equation, and we get that r squared equals to 5. Here we take a root out of this equation, and finally we get that the radius r that we are looking for is equals to the square root of 5 units in its length. In terms of numbers, square root of 5 is 2 times 2, 3, 6 units in its length. Repeat again, we should find out that the radius r of this circle is equals to either square root of 5 units in its length, or in terms of numbers, it is equals to 2.236 units. Okay, so in the next step, I will summarize the lecture. In this lecture, we found out the radius of this circle. So, in the drawing, again, in this lecture, we found out the radius of this circle. So, in the drawing, we have here chord DB equals to 2 units in itself, chord AC equals to the square root of 2 units in itself. This is again DEB, that is equals to 45 degrees in size. Again, our mission is to find out the radius of this circle. So first of all, we join points A and D together by a straight line. We join points A and D together by a straight line. And by joining points A and D, we get the peripheral angle ADC. This peripheral angle ADC, we define the size of this peripheral angle ADC as y over 2. Again, peripheral angle ADC equals to 1 over 2 degrees in its size. We define the center of this circle at this point as point O. Then we know that peripheral angle ADC subtend on chord AC. Again, peripheral angle ADC subtend on chord AC. In the next step, we join points O and C together by a straight line, and we join points O and A together by a straight line. By joining points, by doing this construction, we get the straight angle AOC. This straight angle AOC subtend on the same chord called AC. Exactly like peripheral angle ADC that also subtend on the same chord called AC. So now we can implement here rule 13. According to rule 13, the central angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle, and this is peripheral angle ACB that subtend on chord AB. Likewise, we also have here the central angle AOB. This is central angle AOB that subtend on the same chord called AB. And according to this rule, rule 13, the size of this triangle AOB must be twice as large as the size of this peripheral angle ACB. Why? Because of the fact that those two angles, they are both subtended on the same chord called AB, and therefore the size of the center angle must be twice as large as the size of the peripheral angle that is subtended on the same chord called AB. And the size of peripheral angle ACB is theta, therefore the size of this rectangle AOB must be equal to 2 theta. So we can actually implement Rule 13 in our drawing. Why? Because in our drawing we have peripheral angle ADC is equals to y over 2 degrees in its size according to our definition, and peripheral angle ADC subset on chord AC. Likewise, we also have center angle AOC. This is center angle AOC that's subtended on the same chord called AC, and therefore, according to Rule 13, the size of the center angle AOC, this angle AOC, must be twice as large as the size of peripheral angle ADC. Why? Because both of them are subtended on the same chord called AC. So the size of peripheral angle ADC is y over 2. Therefore, the size of the size of center angle AOC must be equal to y over 2 times 2. That is y, according to Rule 13. Okay. So the size of center angle AOC is twice as large as the size of this peripheral angle ADC. Why? Because both of them subtend on the same chord called AC. Likewise, we defined the size of peripheral angle BAD. This is peripheral angle BAD. We define the size of this peripheral angle BAD as x over 2. And we know that peripheral angle BAD subtend on chord DB. Again, peripheral angle BAD subtend on chord BD. In the next step, we join points O and B together by a straight line, and we join points O and D together by a straight line. By doing this construction, we created center angle BOD. This is a center angle BOD that subtends on chord DB. Again, center angle BOD subtends on chord DB exactly like peripheral angle DAB that also subtend on the same chord called DB. Now, according to Rule 13, the size of the center angle DOB must be twice as large as the size of this peripheral angle DAB, because both of them subtend on the same chord called DB. So the size of this peripheral angle DAB is x over 2. Therefore, the size of this center angle DOB must be equal to x. Okay. So in conclusion, we have found out that center angle AOC equals to y degrees in its size, and this is center angle DOB is equals to x degrees in its size according to Rule 13. Okay. In the next step, I copied triangle DAE, this triangle DAE in a new page, and implemented Rule 4 in this triangle DEA. This is triangle DAE that are going from the original drawing. Those two angles, x over 2 and y over 2, they are both interior angles of this triangle ADE, because of the fact that they are located inside the triangle. This is angle DAB that is defined as an exterior angle in relation to this triangle DAE, because of the fact that angle DEB is located outside triangle DEA. So So angle DEB is an external angle. The size of the external angle DEB is 45 degrees, and those two angles, x over 2 and y over 2, they are both defined as interior angles of this triangle DEA. Now we can implement here rule 4. So I print quickly on rule 4. According to rule 4, the external angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So here in the drawing this triangle, and those two angles A, B, and C, they are all defined as interior angles of this triangle because they are located inside the triangle, while this is angle E that is defined as an external angle in relation to this triangle because it is located outside the triangle. According to this rule 4, the size of the external angle E will be equal to the sum of the two interior angles that are not adjacent to it. This is angle C that is adjacent to angle E, and the two other angles that are not adjacent to angle E are A and B. So the size of angle E is equal to A plus B, and A plus B equals to E. Well, because the size of the external angle E equals to the sum of the two interior angles that are not adjacent to it. The two interior angles that are not adjacent to it are A and B. Therefore, the external angle E equals to A plus B degrees in its size. So we can actually implement rule 4 in our drawing. In our drawing, we have triangle ADE. Inside triangle ADE, we have those two angles, x over 2 and y over 2. And we have also angle DEB, that is defined as an external angle in relation to this triangle DEA. And the size of the external angle DEA is 45 degrees. The size of the external angle DEB is 45 degrees. According to rule 4, the size of the external angle DEB must be equal to the sum of the two interior angles that are not adjacent to it. The two interior angles that are not adjacent to it are x over 2 plus x over 2 and y over 2. So according to rule 4, the size of this external angle DEB must be equal to x over 2 plus y over 2. Angle DEB equals to x over 2 plus y over 2. But angle DEB equals to 45 degrees according to what is given in the question. So substitute DEB by 45 degrees, and we get that 45 degrees equals to x over 2 plus y over 2. Here we'll multiply this equation by 2 and finally get that x plus y equals to 45 degrees times 2, that is 90 degrees. So x plus y equals to 90 degrees. We subtracted x from this equation and finally found out that y equals to 90 degrees minus x. This is according to equation 1. Y equals to 90 degrees minus x. In the next step, I copied triangle BOD. This is triangle BOD that I copied from the original drawing, and we implemented the law of cosines in this triangle BOD. So actually, this is triangle BOD that I copied from the original drawing. According to what is given as the question, DB equals to 2 units in its length. DO and BO, they are both the radii of this circle, and we find the radius of this circle is R, therefore they are both equal to R. And this is angle X. Repeat again that we implemented the law of cosines in this triangle DOB. So I repeat quickly on the law of cosines. First of all, the law of cosines is true in any triangle. So in any triangle, cosine theta equals to a square plus b square minus c square over 2 times a times b. Again, cosine theta equals to a square plus b square minus c square over 2 times a times b. So we can actually implement the law of cosines in any triangle, and especially we can implement the law of cosines in this triangle, triangle DOB. In triangle DOB, according to the law of cosines, cosine x will be equal to r squared plus r squared minus 2 squared, that is 4, over 2 times r. Again, cosine x equals to r squared plus r squared minus 2 squared, that is 4, over 2 times r. R squared plus r squared is 2r squared, so in total, in the numerator of this expression, we have 2r squared minus 4, divided by 2 times r, that is 2r squared. So cosine x equals to 2r squared minus 4 over 2r squared. 2r squared over 2r squared is 1. And we have also here minus 4 over 2r squared. So in conclusion, we found out that cosine x equals to 1 minus 4 over 2r squared. Here we divided both the numerator and the denominator of this expression by 2. And found out actually that minus 4 over 2 is minus 2, and 2r squared over 2 is r squared. So in conclusion, we found out that cosine x equals to 1 minus 2 over r squared, according to equation 1. Repeat again, we found out that according to equation 1, cosine x equals to 1 minus 2 over r squared. Okay. In the next step, incorporate this triangle AOC in a new page, and implemented the law of cosines in this triangle AOC. Actually, this is triangle AOC that according to our drawing. This is angle y. Side AC equals to the square root of units in its length. Both AO and CO, they are both the radii of the circle, and therefore each of them is equals to r according to our definition. Now we implemented the law of cosines in this triangle AOC. According to the law of cosines in triangle AOC, cosine y will be equal to r squared plus r squared minus square root of 2, that is 2, over 2 times r. Again, cosine y equals to r squared plus r squared minus 2 over 2 times r. R squared plus r squared is 2r squared, so in total, in the numerator of this expression, we have 2r squared minus 2, divided by 2 times r, that is 2r squared. So in conclusion, we shall find out that cosine y equals to 2r squared over 2r squared is 1, and we have also minus 2 over 2r squared. Here we divided both the numerator and the denominator of this expression by 2. So in total, cosine y equals to 1, and minus 2 over 2 is minus 1, and 2r squared over 2 is r squared. So in conclusion, we found out that cosine y equals to 1 minus 1 over r squared. So again, we found out that cosine y equals to 1 minus 1 over r squared according to equation 2, and according but we already found out that y equals to 90 degrees minus x. Now we can substitute y in this equation 2, by 90 degrees minus x. We did it and found out actually that cosine y is 90 degrees minus x, equals to 1 minus 1 over r squared. Here we use the trigonometric identity that says that sinus x equals to cosine 90 degrees minus x. So now we can substitute cosine 90 degrees minus x by sinus x. We did it and found out that according to equation 2, cosine 90 degrees minus x is sinus x, so sinus x equals to 1 minus 1 over r squared. This is according to equation 2. Again, according to equation 2, sinus x equals to 1 minus 1 over r squared. Well, according to equation 1, we shall find out that cosine x equals to 1 minus 2 over r squared. In the next step, use the trigonometric identity. Use the trigonometric identity that states that sine square x plus cosine square x equals to 1. We have already found out that according to equation 2, sinus x equals to 1 minus 1 over r squared, but according to equation 1, cosine x equals to 1 minus 2 over r squared. Now we can substitute sinus x in this trigonometric identity by 1 minus 1 over r squared, and we can substitute cosine x in this trigonometric identity by 1 minus 2 over r squared. We did it, and in this way we created equation 3. So according to equation 3, sinus square x. We have sinus square x. So sinus x is 1 minus 1 over r squared, therefore sinus square x will be equal to 1 minus 1 over r squared plus cosine square x. Cosine x is 1 minus 2 over r squared, therefore cosine square x will be equal to 1 minus 2 over r squared. And it is equals to 1 according to this trigonometric identity. So, actually we get equation 3 that says that 1 minus 1 over r squared plus 1 minus 2 over r squared equals to 1. In the next step, we substitute, actually we defined t is 1 over r squared. Again, t equals to 1 over r squared according to our definition. And therefore we can substitute 1 over r squared in this equation by t. And we did it, we actually found out that according to this equation 3, we have here 1 minus 1 over r squared, and 1 over r squared is t. So this expression equals to 1 minus t squared plus 1 minus 2 times 1 over r squared. So we substitute 1 over r squared by t, and we actually found out that this expression equals to 1 minus 2 times 1 over r squared. 1 over r squared is t. So this expression in total equals to 1 minus 2t squared, and it equals to 1. So according to equation 3, we actually found out that 1 minus t squared plus 1 minus 2t squared equals to 1. Here open the brackets on this side of the equation 3, and we actually found out that 1 minus t squared equals to 1 squared plus t squared minus 2t plus 1 minus t squared, 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared, that is 4t squared, minus 2 times 2t, that is minus 4t, is equals to 1. So, we actually found out that after we open the brackets on this side of the equation, in total we found out that actually that 1 plus t squared minus 2t plus 1 plus 4t squared minus 4t equals to 1. Here we have 1 on both sides of the equation, so 1 we have cancelled. After we cancelled 1, in this side of the equation we have t squared plus 4t squared, that is 5t squared, and we have also minus 2t minus 4t, that is minus 6t, and we have also here 1. This is 1 is equals to 0. Equation, we found out that according to equation 3, 5t squared minus 6t plus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0, the variable that we are looking for is t. So x equals to t, the coefficient a equals to 5, the coefficient b equals to minus 6, and the coefficient c equals to 1. The only thing that is left to do is to put this our specific quadratic equation inside this general formula for x, and we find out the value of the values of t, because x equals to d. We did it, and x equals to t, so we substitute x by t, and it is equals to minus b. b is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. b is 6, b is minus 6, therefore b squared is minus 6 squared, that is 36, minus 4 times a. So a is 5, so minus 4 times 5 is minus 20, times c. c is 1, so minus 20 times 1 is minus 20 times 1 is minus 20. So inside the root we have in total 36 minus 28 over 2a. a is 5, so therefore 2a is 2 times 5, that is 10. So we found out that t equals to 6 plus minus, and inside the root we have 36 minus 20, 36 minus 20 is 16, so inside the root we have only 16 divided by 10. And the square root of 16 is 4. So again, we can find out that t equals to 6 plus minus, again the square root of 16 is 4, divided by 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So according to the first solution for t, t equals to 1. But according to our definition, t equals to 1 over r squared, so we can substitute t by 1 over r squared. We did it, and found out that t that is 1 over r squared equals to 1. Here we multiply this equation by r squared, and finally found out that r squared equals to 1. We took out of this equation, and finally found out that the radius r that we are looking for, it is equals to the square root of 1, that is 1. So according to the first solution, the radius r of this circle equals to 1 unit in its length. But it is impossible that the radius r of this circle equals to 1. Why? Because we know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. Okay, and we have a chord dB that is not the diameter of the circle. Again, chord dB is not the diameter of the circle, and it is equals to 2 units in its length. Again, chord dB that is not the diameter of the circle, it is equals to 2. And therefore, the diameter 2r of the circle must be greater than dB that is not the diameter. Again, the diameter 2r of this circle must be greater than dB that is not the diameter. Why? Because the diameter is the longest chord in the circle. So the diameter 2r must be greater than dB that is 2. From this inequality, we derive that 2r is greater than 2. Here we divide this equation by this inequality by 2, and finally we get that r is greater than 2 over 2 is 1, so r is greater than 1. So if we found out that the radius of this circle must be greater than 1. If the radius must be greater than 1, it cannot be equal to 1. Therefore we cancel the solution, and we are left only with the second solution that is possible for t. According to the second solution for t, t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So according to the second solution for t, t equals to 1/5. But according to our definition, t equals to 1 over r squared, so we can substitute t by 1 over r squared in this equation. We did it, and we found out actually the t that is 1 over r squared equals to 1/5. So 1 over r squared equals to 1/5. Because multiplied this equation, and finally found out that r squared equals to 5. We took out of this equation, and finally found out that the radius r of this circle equals to either square root of 5 units in its length, or in terms of numbers, the radius r of this circle is equals to 2.236 units in its length. Okay, thank you very much.